Hello students, welcome to this session for lecture on chapter 2, right? So I think this is the third part 3 of the lecture on chapter 3. Oh, sorry, right? Part 3, chapter 3. So we are now going to discuss 3.5. So this is marginal utility and consumer choice. We have so far discussed, right, about the tangency point between the highest standard attainable indifference curve and the budget line. That is the consumer choice. That is where at that tangent point, if I just make a quick sketch here, this is the indifference curve IC, right? This is indifference curve, suppose we call it IC, and this is the budget line, right? This is the budget line, the origin. Look at that point of tangency, right? At that point of tangency, we said the budget line tangent to the highest attainable indifference curve. That is where utility of the consumers will be maximized. And in our example, previous slide, we were measuring consumption of food on this axis, right? And consumption of what? Clothing on this axis. Remember, the consumer has a certain amount of income to spend, and price of food is PF and price of clothing was PC, right? And we showed you how the slope of the budget line is equal to slope of the indifference curve, which we defined as what? Which we defined as MRS, marginal rate of substitution, right? And slope of the budget line was given as ratio of price of food divided by price of clothing. This condition will be fulfilled at that point of tangency here, right? At that, so if I want to highlight point of tangency, that red. Okay, so let us now explain this same thing in another concept. So we see marginal utility MU, let us define it. Additional satisfaction obtained from consumption of one additional unit of a good, right? So marginal utility of X will be the how much total utility change because when the consumer consume one more unit of X. Look at that ratio. Change into delta stands for change, right? Delta TC divided by delta X, that will tell us how much total the TC, not TC, TU, total utility, TU, right? So total utility will change corresponding to a given change in X. So when you take that ratio, this ratio tells us how much total utility will change when you consume one more unit of food X, item X. So here for us, this is marginal utility of what? Marginal utility of food, right? And similarly, we will have marginal utility of clothing, right? So see, and now diminishing marginal utility. We make this assumption, diminishing marginal utility. It says that the principle that as more of a good is consumed, the consumption of additional units of the same good will yield smaller additionals to utility, which means that for marginal utility of X, this one is if you consume more and more of X, so each successive unit of X will have lower and lower marginal utility. Your total utility will increase, but it will increase less and less as you consume more and more of X. So that is diminishing marginal utility. And we say that this marginal utility of food, right, is subject to that diminishing marginal utility. Also marginal utility of clothing subject to that diminishing marginal utility. Now let us see what is happening here. This is the equation for an indifference curve. What is going on? See, remember, along the same indifference curve we said what? Look at that IC, IC, right? Along the same indifference curve, utility does not change. See, indifference curve is the combination of all those different combinations of food and clothing, right? Food and clothing, but we have same total utility along a single curve, right? So when we go from one point to another point, right? So this is change in food, this is change in consumption of clothing, and this change in how much will utility will change when consumption of food change by delta F. We multiply that delta F with marginal utility of C. Marginal utility of F is telling us how much utility will change, total utility will change when we consume one more unit of food. And on the other hand, this delta F tells us what is the change in total unit of food. So together, when you multiply together, all of this tells us change in utility coming from a change in consumption of food. On the other hand, similarly, marginal utility of clothing multiplied by change in clothing tells us how much will total clothing change, how much will total utility change, total utility change when there is this change in clothing, right? Because of this delta change in clothing. So let us see what are they saying. So suppose we are here, right? This is our initial consumption of food, initial consumption of clothing. Then we have to go to the indifference curve, right? Here, that one. So let us erase the first line. And then we go to another point on the indifference curve. See, from this point, so this is how much clothing we have now. This is how much food. See, food consumption of food, delta F is that. Consumption of clothing is what? Delta clothing is that, right? And then we are moving from the one point to another point, but on the same indifference curve. So in utility will not change. Our gain, look at that. When we have more clothing, we are left with less. When we have more food, right? Have more food, we are left with less clothing. So the utility that we gain because of having more food is compensated by the utility we lose by consuming less clothing. This is always true because look, the indifference curve is like this. So when you move from one point to another point like that, right? Like that. So I'm just giving you the idea. Indifference curve, so what happens? It will always be such that this is food, right? F, 0 origin, and this is clothing. When you increase food, it will always come at the cost of what? Cost of clothing. So remember the trade-off. MRS shows us that trade-off. MRS, remember we said MRS is what? MRS is the ratio of change in clothing, change in food. This tells us how much clothing we want to sacrifice for one more unit of food, right? And that is the slope of the indifference curve. So we get the idea, right? Change of total utility along the same indifference curve is 0. All these combinations on that same indifference curve is going to be what? Is going to be give us the same level of utility. Okay, now we understand. So we know that this is actually telling us about an indifference curve. So now what we do is algebra, right? Simplify. We will what? Change sides, and then what? Change all of this. All of delta C and mu C, delta C, all of this, take it on this side, right? And then what happens? We cross multiply and then bring delta F from here on the other side, and we bring so let us see if I want to show you here. Marginal utility of C, delta C, we took it on the other side, right? And plus it will become a minus. And then we have on the left hand side, right hand side, we still have leftover marginal utility of food, and this is change of food. See, and now delta C and delta F, we cross multiply, take this delta F on the other side and take this marginal utility of clothing on the other side minus, so let us take on the other side. So here we will be left with numerator marginal utility of food and denominator marginal utility of clothing. See that? So that is how that is exactly what they have. See, so the ratio now this let us keep it here. This one, all of this is actually equal to what? Slope of the indifference curve. See, so that is what they are using here. So from this they get my MRS, and this ratio remains the same, And also we have already said that MR is equal to slope of the budget line here. Remember, we proved it before. So we now know that this one is equal to this one. So we rewrite this and then again cross multiply, change sides, and we get this. What is this telling us? Marginal utility of food divided by price of food. This tells us how much our utility will increase when we spend one more dollar on food. On the other hand, alternately, this side, this ratio, marginal utility of clothing divided by price of clothing, will tell us how much our utility will increase when we spend one more dollar on clothing. So we are saying that at the tangent point right here, remember the tangent point here, at the tangent point, the slope equal to one another, and also before we showed you in the previous slide, we showed you MRA is equal to what is price of food, price of clothing, and now we show you that MRS is also equal to the ratio of marginal utilities, and also which we already know is equal to the ratio of prices, and therefore these two. See, this is called, these two sides must be equal. This condition, this is called equal marginal principle. This principle that utility is maximized when the consumer has equalized the marginal utility per dollar of expenditure across all goods. See, so see, remember we said this ratio of marginal utility divided by price is the what? That marginal utility per dollar of expenditure. See, on the food, and then on the right hand side it is marginal utility per dollar of expenditure for clothing. See that? So that one. So that is the ratio. This again is another way of representing this tangency between the highest attainable indifference curve and this budget line, right? Um, and we know that at the tangent point these two slopes are equal to one another. So that was one condition, but this same condition you can represent in another way, in this way, right? Okay. So let us see what is going on. Example 3.7, marginal utility and happiness. So what if anything, does research on consumer satisfaction tell us about the relationship between happiness and the concept of utility and marginal utility? See, so this is income in 1999. So this is for this axis showing us increasing level of income, right? A comparison of mean level of, and on this side, on the vertical side, we have mean level of satisfaction and life across income classes. These are different income classes, and this is the reported score, right? Satisfaction with life. So you see, people who have low income are less satisfied with life, right? On the other hand, people who have high income is what? More satisfied with life, right? Now what is interesting here is that look at the slope of the curve. See, slope of this curve is marginal utility, right? So this one will tell us how slope of the curve is rise versus run, right? This vertical distance, horizontal distance. Vertical distance, we are measuring happiness, say total utility, and in the horizontal we are measuring income. So this is the slope, right? And the slope, if you imagine slope of this at different points on this curve will be the slope of the tangents. If you draw tangents, successive tangents, right? And compare. So compare the, look at the tangent slope, tangent slope is tangent slope is decreasing, right? Tangent slope is decreasing. So which means that as level of income is increasing, as we go this way, right? Go this way, slope of the happiness curve is decreasing. See, happiness will increase, but it will increase at a decreasing rate. That is what it says. That is what is reflected by that smaller and smaller slope. For every dollar increase in income, Utility, the numerator will increase, but it will increase less and less than before. That is what we are saying, diminishing rate. Now, this is another example of rationing. See what happened if inefficiency of gasoline rationing. So suppose there is in the we are at point C, right? And this is spending on other goods $15,000, spending on gasoline $5,000 for a person when his budget is 20,000. See that? When his budget is 20,000, and he is maximizing utility at U2. Now, when a good is rationed, less is available than consumers would like to buy. Consumers may be worse off. Without gasoline rationing, up to 20,000 gallons of gasoline are available for consumption at point B. So see that here. There is no limit on gasoline consumption. So given this budget line, someone can consume at point B 20,000. But then he will not have any money left over to buy other goods. The consumer chooses point C on the indifference curve U2, consuming 5,000 gallons of gasoline. See? Okay. So this is not $20,000. This is actually what? 20,000 gallons of gasoline. So here, and then what happened? And then without any restriction, the consumer maximize utility at C, right? Look at that at point C. Look the tangent, right? So tangent means that indifference curve MRS is equal to the what? Ratio of price of food, price of fruit, price of clothing. Is it this is the slope of indifference curve, this is the slope of the budget line. However, with a limit, now suppose the government come and introduce this limit, right? Gasoline per ration, the consumer moves to D on a lower indifference curve. So consumer can only consume 2,000 gallons, and the rest of the money he can now spend on food. But yet he's now moving from C to D, right? If you look, D is on a lower indifference curve, so which means that he is actually worse off satisfaction wise, right? He wants to consume more gasoline, but he cannot, so now he's worse off. So he's on a lower indifference curve. And here again, this is not equal, right? Look at that. The budget line at point D, budget line intersects that indifference curve, U1. So if this is U1 indifference curve, this is the budget line. So this is intersection. This is not like what? This is not like the case of a tangent, right? Here at point C we have tangent, but at point D we have what? This is U2, right? At point D we have this intercept on a lower indifference curve. So again, this equality becomes important. If they are not equal, then what? Then this is not going to maximize utility. Now comparing gasoline rationing to the free market. So let us compare now. So you see, so some consumers will be worse off, but others may be better off with rationing. With rationing and a gasoline price of $1, a consumer buys maximum allowable 2,000 gasoline per year, putting her on indifference curve U1. See this consumer U1. She's buying $2,000. Okay, let us see. This, and then had the competitive market price been $2 per gallon with no rationing, she would have chosen point F. This one, chosen point F. So here, see now, before when we said about B, at that time price of gasoline was what? Price of gasoline was $1. The consumer's income was 20,000, right? His income and price of gasoline was $1 per gallon. So total was he could buy 20,000 gallon. But now we are saying that okay, his let us say price of gasoline a free market price of gasoline is $2 per gallon. See, now she can only buy 10,000 gallons with all his money here, which is here, and therefore with no rationing, she would have chosen point F, which lies below the indifference curve U1. So that is, however, had the price of gasoline been only 1.33 per gallon, she would have chosen point G, which lies above indifference curve U1. So the price of gasoline really matters, right? So if the price is changing, right, this is when price is $1, this is when price of gasoline $2, this is when price of gasoline is what, $1.33. See, and here when it is $1.33, then then the consumer will buy at G, and that G is on a higher indifference curve than that D. Yeah, D is correspond to this one D, right? To the D of the previous slide. So they're just giving example that when price of this gasoline changes, the welfare of the consumer will shift, right? Will change also, and we go from one equilibrium to another. But as long as we don't have that tendency, right? As long as MRA is not equal to what? Price of food divided by price of clothing. In our example, food, in this year, it will be price of what? It will be price of gasoline and price of other items, right? Other items. As long as this is not, we don't have that, this is utility is not maximized. Now let us take a look at this one, cost of living index, right? So cost of living index, we use this one to what? To measure change in prices in reference to a base year price level, and this we will use to measure what? Inflation. So let us say cost of living index, ratio of the present cost of a typical bundle of consumer goods and services compared to the cost during the base period. See, so we have a typical bundle. So we will find the cost of buying this bundle at present, right? The present cost, and compare that with that cost with buying the same bundle in the base year period, and then we compare, we find out change in price. Now there are different ways to do this. One is ideal cost of living index. The ideal cost of living index will include cost of attaining a given level of utility at current prices relative to the cost of attaining the same utility at base year prices. See, so here we have to what? Ideal cost of living, they will what? They hold that utility fixed, and then what? And they will compare the cost of attaining that utility now to the cost of attaining the same level of utility years ago, right, in the base year prices. And that is how this type of index will measure inflation. That is how it will measure change in cost of living. So let us see what is going on here. Cost of living index. Suppose we are table 3.3, ideal cost of living index. Price of books is $20 per book in year 2000 for Sarah, right? And then what? Number of books is 15. Then what happens? Price of food $2 per pound. Pounds of food 100, and expenditure is 500. On the other hand, this Rachel you have in 2010, after 10 years, right? So price of book has increased from 20 to 100 per book. 15 to number of books 15 to 6. Then price of food is 2.22. Pounds of food is 100 to 300. Expenditure 5,000 to 1260. The initial budget constraint facing Sarah in 2000 is given by line L1. See that, this one, this L1. So let us see what is going on. Income is 500, right, for Sarah. This one 500. And price of food here, price of food is how much? Price of food is $2. So we know that 500 divided by 2 is 250. On the other hand, here we have what? Again, income is 500. That is his expenditure. That is the money he can spend. 500, and price of book is 20. So if you divide, you get 25. And then we add those two corner solutions, and then get his Sarah's budget line. And then her utility maximizing combination of food and clothes of books is at point A on the indifference curve U1. See that? This is U1 indifference curve, and this is what? Tangent, right? Point A tangent. Is that okay? Okay. So that one. Now let us say that uh, the price of books change, and as a result 20 to 100. So 1260. Now divide that 1260 income, 1260 divided by what? 100. You will see that it is what? It is 12.6, right? Again, if you divide 1260 with the current price of food, which is what? 2.20, you will find that this is what? Somehow like 60. So this is the new budget line. See? So compare old budget line, new budget line. But we have the new equilibrium will be at point B, because this is where the new budget line is tangent to the same level of utility, right? At A, this was the old budget line tangent with U1 utility. Now we have the new budget line L2 is tangent with the at that B. So this is the equilibrium. At the equilibrium, they will now consume 300 food, 300 pound of food per quarter, and what? And 5 books. Before they used to consume 100 pound of food per quarter and buy 15 books. See? So those are the two equilibrium. Now Rachel requires a budget sufficient to purchase the food book consumption bundle given by point B on line L2 and tangent to indifference curve L1. So in both case A and B tangent, so they are maximizing utility. Now this is cost of living index, and this is a price index which represents the cost of buying bundle A at current prices relative the cost of bundle A at base year prices overstates the ideal cost of living index. See, so what we now have L3. So what do we have at L3? At L3, at L3 that is telling us L3 shows us the old bundle. This is, remember, 15 books and 100 pound of food per quarter. But the cost of what is the cost of buying that old combination at that combination A at the new price, this 100 and what 2 for book and 2.20 per pound. That is what L3 will show us, right? So this. On the other hand, this is what we call Laspierre's price index. This tells us the amount of money at current year prices that an individual requires to purchase a bundle of goods and services chosen in a base year. So see, this is the base year, same good and service that we were consuming in base year and A. So what will be the cost of buying that bundle today at today's price in 2010 price compared to the cost of buying A in 2000, right, 10 years ago? That is what Laspierre's index calculates. So chosen in a base year divided by the cost of purchasing the same bundle at base year prices. Now if we now compare ideal cost of living and Laspierre's index overcompensates Rachel for the higher living cost, and the Laspierre's cost of living index is therefore greater than the ideal cost of living index. So see, So let us go. If you calculate the amount of money here, so let us see what is going to happen. So this one was 500 and this is 1260. So let us see at AL3 what is the cost. At AL3 cost is what in the they used to buy 15 books and now find value cost at today's price. So 15 and books and 100. So sorry, it is not 2.2, it is what 15 multiplied by what 100. So that is the cost of 15 books, and this will be 6 multiplied by what and then this will be what 15 multiplied by 100, and this is what 100 multiplied by 2.2. So pounds of food is what pounds of food is 100 multiplied by 2.20, right? 100 pound of food 100, this is 2.20, and this is 15, and this is what 100. So when you this is 1500 plus what 2.20, when you multiply it will be what it will be 122. So it will be 222, and if you add 1500 and 222, it is 1720. See, so they are telling us then this price index, Laspeyres index, is telling us that at A to have the same level of satisfaction. Now before they used to take 500, but with now new prices in 2010, right, in 2000 used to take $500, but now in 2010 it will take what 1700, it will take 1720, right? Okay, now the next one. Laspeyres index. Now another type of index we discuss, Paasche index. Paasche index is this amount of money at current year price level. So now we will consider current year prices that an individual requires to purchase a current bundle of goods and services divided by the cost of purchasing the same bundle in the base year. So see, now what were current, now this time we will focus on the current bundle of goods. So what is the cost of buying that current bundle of goods in today's price, and compare that with the cost at the of the same bundle buying that current bundle in the base year. So if we now go and here, and we are now thinking about B. So let us change color, right, to make a difference. B. So what at B they were buying what? They are buying this 6 point something, right? This is the per book, and this was the food they were buying. So what is the cost of buying this? What is the cost of buying this, right? Buying this, what is the cost of buying this at the base year price, 20 and dollars per book and $2, and what is the cost of buying that B at the current price? So 10 and what 2.20, right? So let us so that will be we find that answer, and that will be the answer for what? For the Paasche index. Okay, so let us now find out. So you see, we now calculated like L4. We are finding out the cost of buying that bundle B, right, at the base year price. So we use this 20 for book and $2 for what? For price of food and and the quantity is coming from the new one, right? B is the 6 and 300. See here, B is 6 and 300. This one. So we find that this is 720, right? So if you now compare, so you will see that in the PASI index will what? PASI index will then understate the amount that is needed, right? That is needed to be on the same level of utility. We need 1260, but PASI is saying that to buy the new good, compare the new bundle, right? B at old price and new price, and it will say that no, 720 for 720 you can be as well as before. You can buy the old combination. But that is true, but that utility will change. See, when price changes, when price of goods change, look at that. Look at that increase in food and increase in what? Increase in food and increase decrease in consumption of books. See, so these indexes do not adjust for that, the fact that we are changing the combination that we buy, right? So we are moving from A to B with different combinations of the goods. Now, now comparing the Laspeyres and PASI indexes, just as the Laspeyres index will overstate the ideal cost of living, the PASI will understate it because it assumes that the individual will buy the current year bundle in the base period. So that is what we have seen, L4, right? Okay. So now economists, they propose that a compromise that we call fixed weight asset index. So cost of living in which the quantities of goods and services remain unchanged, fixed weight, so that to control for the overestimation and underestimation of the PASI and Laspeyres index. And so price indexes in the United States, recently they have also started this chain weighting, also to what? Change weighted price index, cost of living index that account for changes in quantities of goods and services. Remember, as you compare, if you compare between A and B, we are actually trying to find out change in cost for two different combinations of goods, not just two different set of prices. So here, to keep that, to control for that, they have devised Bureau of Economic Analysis and other government agencies now use chain weighted price index. The bias in the CPI, a commission chaired by Stanford University professor Michael Boskin, concluded that the CPI overstated inflation by approximately 1.1 percentage points, a significant amount given the relatively low rate of inflation in the United States in recent years. Approximately, so for this, if we look into this 1.1, right, inflation for the last decade was what? About say 3%. And just imagine, out of that 1.1 is due to what? Due to this error. So the professor also says that approximately 0.4 percentage points of the 1.1 percentage point bias was due to failure of the Laspeyres price index to account for changes in the current year mix of consumption. See, combination, that commodity bundle is changing. Less books and what? More food. So that combination is changing. So the products in the of the products in the base year bundle. So that is the thing. Base year bundles, they become obsolete. So we should not use them for a long time, because base year that was there long time ago will be really obsolete. Will give us misleading information. Okay, thank you. That this was the last part for lecture on slides for chapter 3. Thank you.